This is my website. If you want to get in touch, this is my URL. I even you need to refresh it. I've put my email address in the middle of the page since yeah. So any similarity between this logo and the Sun Microsystems logo is purely intentional, and Holistics, I don't know if you're familiar with Douglas Adams, The Hitchhiker's Guide to the Galaxy, of course you are, and Dirk Gently's Holistic Detective Agency. It was an idea that a friend and colleague, Adrian Cockcroft, raised as the idea of a holistic performance agency. So that was, for 20 years at Sun, that's what I was interested in, was systems performance, not just a file system or an I/O system or a VM system, but the whole system, including the network and what was out on the other side of the network. So I left Sun before it ceased to be Sun, and because the prospect of it being anything else was too difficult for me, having invested 20 years with Sun. And so I am a independent, self-employed, freelance systems performance consultant. And I'm not the first one to stand here today and say I'm for hire. I'm a little bit heavier weight than the other guy, although I wasn't there as a founder, architect of ZFS. If you want help in this time zone, I'm near, and I'm cheaper to fly. But sometimes you do need an architect, and I'm sure we'll share the workload. Yeah. It was interesting. We talked about when did we first use ZFS. So and I have to really substantiate how I had this T-shirt for actually putting ZFS into production. You can find it on this blog actually. I've got a copy of my Sun blog under that button there. But what was a bit of fun, and it was ZFS. So I think I'll just mention it now. BNP Paribas had a portfolio management application running with an ISAM database. And it really didn't scale very well for reporting purposes. So what we did was we did a lot of work with dtrace to find out where the scalability issues were, and we discovered that we really couldn't do anything about it. It was all application code. And I did a little bit of lateral thinking. We had an E25K with 144 CPUs. It would only scale to about 48. But most of the batch workload it was doing at night was report generation, which didn't require the database to be actually to move forward. You could just work on a copy of the database and throw it away when you've done report generation. And there was a particularly sweet spot at 24 CPUs where it was almost linear scalability. So what we did is we put everything in ZFS. The ISAM database loved ZFS. It loved its caching, loved its locking. And at the point in the night where we wanted to do the report generation, we just snapshot and clone the 120 gigabytes of working set data that we had, all of which was in 200 gigabytes of RAM. So the cache was nice and hot, and because of ZFS being copy on write and all the data was already in cache, we could then clone that 5 times, create 5 zones for running read-only reports in, and get a 6x performance boost for no cost. Yeah, because you could instantiate a report zone in 30 seconds using ZFS cloning again. So that was 8 years ago, and something that was a real-world solution. And it was the sort of thing you just couldn't do any other way. Yes, you could buy a distributed system, but you'd have to copy that 120 gigs of data into caches around your grid, and it was already there. And copy on write did all the work for us. So that was the first attempt. But I wanted to talk about something a little bit more. Now, you were hoping I was going to talk about PIC microcontrollers. But I wanted to pick on something older, and that's the PIC system. Richard Dick Pick. I don't know if any of you have heard of that. The PIC system. No, you're all too young, you see. In about 1965, the US Army was looking at new, and actually this is the precursor to the NoSQL movement. Before there was an SQL, there was a NoSQL movement. And the pre-relational or maybe post-relational multi-value database system that was PIC, and it was a system. It was an entire operating system, multi-user, virtual memory, demand paging, and it had its own very quirky. It has its very own quirky file store, and there are actually a large number of people still using PIC systems today. Prime had PI Open, which was a Prime Information PIC environment, and then IBM bought something called Unidata, and another product called Universe, and these are today supported by and developed by a company called Rocket, who have hundreds, thousands of customers, and something like 50% of Fortune 100 companies are using PIC today, and one of them is one of my customers. Actually, not a Fortune 100 customer, but they are one of the UK's largest courier companies, and it's used a lot across manufacturing, across distribution, really across the industry. And one of them just landed on my desk. We have a performance problem, can you come and help me? So I went along, had a look, and this PIC environment is arcane, to say the least. It's a shared nothing environment, the universe environment. So it relies on the file system to cache all the data for it. It likes to do 2K I/O. Well, 640K is more than anyone would ever need, and so it likes to do 2K I/O, and it relies on inter-process communication so that people don't tread on each other's toes in the cache, in the file system cache. But this particular customer had data files that were growing to over 50 gigabytes in length every month, and it was becoming, if you're familiar with POSIX and the POSIX semantic that requires a single writer to a file at a time, so that all writes are serialized to a file. UFS in Solaris used to have a little thing called direct I/O, which allowed you to miss out on the reader-writer lock per file, but also had the side effect, of course, of bypassing the cache, and Universe required everyone to use the cache because you really don't want to do that many 2K I/Os direct to disk. So I was just walking one day, as I think we'd gone off to lunch, and it suddenly clicked. I think I heard in a talk somewhere that ZFS does region-based locking when it comes to the POSIX constraints. It actually relaxes it's not POSIX compliant technically, but it relaxes the constraint so that no two writers can overwrite the same region of the file at the same time, which just happened to be the feature I needed. And the rest is history. We slotted that in, and now we were able to grow the throughput of the system with ZFS to levels that the business was growing exponentially, as often is the case, and we were able to grow the throughput of the system because of this region-based locking in ZFS. And along the way, we found all sorts of other interesting things. This system, on a busy day, is doing 500,000 2K reads per second. And we found a lock, and you must know about this one, the MRU for the ARC MRU lock. You're familiar with the most frequently used partitioning, and because most of this was hammering hard on frequently used, it was the MFU latch actually. We discovered all sorts of scalability problems with that. Now this is where I have to just confess that in my work I'm not proud about who I work with. I do actually work with people who run Solaris. and Linux. I've done some great work with some people running FreeBSD. Very exciting to hear everything that's going on about there. If it's ZFS, then I'm interested. If it's got dtrace, I'm interested. And so we've pressed forward on this, delivering mission critical, high performance, large scale transactional processing. This is, see, most of you guys, I guess, are more interested in storage, but this is doing both examples I've given you are databases that are running mission critical, large scale, industry leading, high volume workloads. One other experience perhaps I would share, as well as the latch issues, but Oracle were able to have done, I don't know if you've done any work on ARC, MRU and MFU. But
very recently.
Yeah, great, because it was becoming quite an issue for people. I don't know if it's so much an issue for people with storage with NAS appliances, but certainly for what I was doing, it was a severe limitation. That's good to know. But the other area of interest is, I don't know if you've ever thought about the MRU, most recently used, most frequently used partition. It's only recently that people have started throwing huge amounts of RAM at the ARC. A lot of people have less than 128 gigabytes. And my customer started with 128 gigabytes of RAM and gave about 80 to the ARC. And we would find that under steady state, after running several days, it would partition to about 40 gigabytes of MRU and 40 gigabytes of MFU. And then they invested and bought a system with 512 gigabytes of RAM. And what that does is it increases the amount of time an object can be in the most recently used and then become promoted into the most frequently used. So you get longer to get promoted. So the time base over which you're allowed to be frequently used increases. And what this does is it tips the ARC from being fairly nicely balanced, in our case with 80 gigs, about 40-40, to, well, we went to something like 450 to 10. So you've gone from 50-50 to almost 50 to 1. And because the MRU had dropped from 40 gigs to 10 gigs, there were some jobs that no longer complete within their window, so we ended up rebooting every 2 or 3 days. You don't expect that sort of thing to happen, and that's why I'm interested in the holistic performance thing. And well, we just added RAM. That's always going to make things better, isn't it? But not in this case. And I'd be interested to know if anyone else has seen that sort of behaviour, because one of the things I would like to be able to do is actually hard configure the partition and not let ZFS move it itself, because I don't think the algorithm is actually working well enough for enough people anymore. I think we don't even know how it behaves on large memory systems. So if you've got any experiences of that, please drop me a line. I'd love to hear from you. And if you've got any ZFS dtrace system performance issues, I'd also love to hear from you. And I'm hoping, I'm really encouraged by this. It's brilliant. I've just really enjoyed all the talk so far. I'm particularly excited about what's happening with FreeBSD, and that some of the issues that I've been rubbing up against, such as lock contention and deadlocks, I've seen those with Netatalk. I'm excited that we actually understand where that's happening. So thanks very much.
Does anyone have any questions for Phil, or any kind of things about performance or tuning or anything that you want to have any questions answered by the man himself while he's here? Won't be charging you a lot of money while the longer I can make him stand up here, the more free information we can get.
I'll just heckle you and say that I'm pretty sure that the POSIX spec requires only that overlapping writes be serialized.
I don't think I even thought that far ahead, though.
So it's just that most file systems implemented that
Yeah.
the simple way by just having one lock on each file, and we actually went to the trouble of implementing range locks.
Oh, well done you. It's paid my bills for a couple of years, that one.
Are there any, maybe one for Matt actually, but are there any tunables for MFU and MRU? So I mean, is there any way that you can say, because I know there's an algorithm that controls it, but is there any way of saying, no, use all this for MFU or use all this for MRU? There isn't. Should there be?
There are ones that there are tunables that look like they do,
I saw some.
like ArcP, and there are other ones to do with the relative the starting points and end points for P and all this sort of stuff. And I have tested them extensively and discovered that they do absolutely nothing.
Yeah, I have similar
because
experiences,
the big thing to remember is that a lot of the time that ArcP itself is considered a hint, and you actually have to get into a situation where you're actually asked to. You see, it'll only move. It'll only attempt to move P when it feels there is a need, some pressure somewhere, and you've got to create the right pressure. And all I've ever seen it do is come down, and then I can never get it to go back up again, because the MFU pressure is huge. You know, once you're in the MFU, it's very hard to evict you.
okay. So ZFS is the passive aggressive file system.
Yeah, that's right.
Well, thank you very much for that, Phil.